I am working with a dataset. It's the foundation of my feature selection problem. Break time 200 milliseconds. It contains information on 10 different features and whether each data point belongs to one of two categories, a binary class. Label, break time 200 milliseconds. Think of it like this Google style name. Excited. Imagine you are trying to predict whether someone will click and attain different characteristics. Features might be used, and the outcome is either click or no click. Binary class label Google style. These are the results from the ANOVA analysis of variance f-test. Each number represents how strongly each of the 10 features is associated with the class label. A higher F statistic suggests a stronger relationship. Think of it like a score. Higher scores mean the feature is more likely to help us distinguish between the two classes. This is my threshold for deciding if a feature is important enough to keep. It's a common value used in statistics. Break time 200 milliseconds. I will only consider a feature to be important if its probability of being wrong p-value is less than 5. Break time 200 milliseconds. Google style name emphatic. It's like setting a bar. Only features that clear this bar get selected. Google style. This is the function I used to perform the feature selection. It's part of a popular Python library, scikit-learn, that provides a straightforward way to calculate those F statistics and their associated p-values. Break time 200 milliseconds. I use it to quickly assess the importance of my features. Break time 200 milliseconds. It's like a handy tool in my toolbox. After running the fclassif function and comparing p-values to the chosen significance level 0.05, I'll decide which features are important enough to keep for my classification model. These are the features that passed my significance test. Break time 200 milliseconds. Their p-values were all below 0.05, indicating a statistically significant relationship with the class label. These are the features I'll focus on moving forward. Break time 200 milliseconds. I've selected them based on the p-values that I calculated. These are the key outputs from my fclassif function. The F statistic shows how strong a feature's effect on the class label is, while the p-value helps me determine if this effect is statistically significant. Break time 200 milliseconds. Think of the p-value as a measure of confidence. Break time 200 milliseconds. Google style name conversational. A low p-value indicates a strong chance that there is actually a connection between the feature and the outcome. Google style. This describes my data. I have 10 different characteristics features for each data point, and each data point belongs to one of two possible categories. Binary class label. This is the overall goal. I am using the fclassif function to determine which of the 10 features are most relevant for predicting my binary outcome. I want to select the most useful features, ensuring that the model is efficient and effective. Break time 200 milliseconds. It's like choosing the right ingredients for a recipe. I am working with a dataset. It has 10 different characteristics. Say as interpret as characters, features say as that describe something, and a label that tells me what category or class each thing belongs to. In this case, only two say as interpret as characters. Binary say as categories are possible. Break time 300 milliseconds. I am using a tool called say as interpret as characters fclassif say as, which is part of a Python library called say as interpret as characters scikit-learn say as. It helps me decide which of my 10 features are most important for classifying the data. Break time 300 MSIT does this by performing an ANOVA analysis of variance f-test for each feature. Break time 300 milliseconds. I've set a significance level of 0.05 or 5. This means I am willing to accept a 5 chance of incorrectly saying a feature is important when it really isn't a false positive. Break time 300 milliseconds. It's a common threshold in statistics. Break time 300 milliseconds. For each feature, say is interpret as characters fclassif say is gives me a p-value, a probability. If this probability is less than my 0.05 threshold, I consider the feature to be statistically significant and keep it. Otherwise, I discard it. Break time 300 milliseconds. It's my decision rule. Break time 300 milliseconds. After comparing the p-values to my alpha, I've selected features with indexes say is interpret as characters 0, 3, 5, 7, 8, and 9 say as a significant. These features are deemed statistically important for my classification task. Break time 300 milliseconds. This shows the results from the f-test performed for each feature. Break time 300 milliseconds. A higher f statistic suggests the feature is better at separating my data into two categories. Break time 300 mshowever. It's the p-value, not the f statistic, that ultimately decides whether a feature gets selected. Based on the feature selection results and the information about the say as interpret as characters p say as values and say as interpret as characters alpha say as. I am answering a multiple choice question to test my understanding of the process. Break time 300 milliseconds. Google style name lively. It's a quiz. Google style break time 300 milliseconds. This is the overall goal of my analysis. I am using the say as interpret as characters fclassif say as function to choose the most useful features from my dataset. Break time 300 milliseconds. I have a dataset. Google style name emphasis perfect Google style for testing my feature selection skills. It has 10 features and a binary class label, meaning each data point belongs to one of two groups. These are the results from applying an ANOVA f-test, which measures how well each feature separates the two groups in my dataset. A higher value suggests better separation. Break time 300 milliseconds. Indicates there are more numbers in this sequence which are not given in the context. This is the threshold I am setting. I'll select a feature only if there's less than a 5 chance that I am seeing this level of separation by pure luck random variation. It's like saying, Google style name enthusiastic. I am 95 confident that this feature makes a real difference. Google style. To decide which features to keep, I compare each feature's p-value probability of observing the result if there is no difference between groups to my significance level. If the p-value is less than 0.05, the feature is deemed statistically significant and selected. I am basically saying, Google style name excited this feature is a keeper. Google style, based on my p-value comparison. Features 0, 3, 5, 7, 8, and 9 made the cut. Google style name lively woohoo. Google style these features stand out as strong indicators of class separation. My dataset is organized around 10 different characteristics features, and each data point has one of two possible labels which helps categorize each data point into one of two categories. I am using a statistical method called ANOVA f-test analysis of variance implemented in the Sklearn library as fclassif. It helps me see which features have the strongest statistical relationship to the class label. The ANOVA f-test gives me two pieces of information for each feature: the f-statistic, a measure of how well the feature separates the classes, and the p-value, the probability of observing the f-statistic if there's no relationship between the feature and the class label. Google style name helpful. These are key to my feature selection decision. Google style. I am using the say as interpret as characters fclassif say as function from Sklearn, a popular machine learning library, to pick the best features from my data. Break time 300 ms. This function helps me choose the features that are most helpful in classifying data. I have a dataset with 10 different features. Think of them as characteristics or properties of things in a binary class label. Break time 300 ms. This means the data points can only belong to one of two groups or classes. The say as interpret as characters fclassif say as function uses the ANOVA F test, a statistical test to figure out which features are most strongly related to my class labels. Break time 300 ms. It basically tells me how good each feature is at separating my two classes. These are the F statistic scores. Break time 300 ms. Each number represents how well a particular feature separates the classes. Higher scores indicate better separation. These are p-values. Break time 300 ms. They tell me the probability of seeing such a strong separation or even stronger by pure chance, if there were actually no real relationship between the feature and the class. I've set my significance level alpha to 0.05 or 5. Break time 300 ms. This means I am willing to accept a 5 chance of making a mistake in this case, selecting a feature that doesn't actually affect class separation. I am selecting the features based on their p-values and significance level. After comparing p-values against the significance level, I chose features 0, 3, 5, 7, 8, and 9. These are the ones I consider important for predicting the class label. Statement A is correct, as features 0, 3, and 7 are among the selected features. Statement B is correct, as features 1, 4, and 6 weren't selected because their p-values exceeded the significance level. Statement C is correct because I selected 6 features more than 5. Statement D is incorrect. While a high F statistic suggests a strong relationship, the p-value decides whether it is significant enough to be selected. A high F statistic with a high p-value above alpha would not be selected. We're working with a dataset that has 10 different features, and each data point belongs to one of two classes. Think of it like trying to sort apples and oranges based on their weight, color, and size. Each of those is a feature. Break time 300 milliseconds. This shows the results of an ANOVA F test for each of the 10 features. Break time 200 milliseconds. A higher F statistic means a feature is better at separating the two classes. Google style name excited. It's like a competition, where a higher score means the feature is a better class predictor. Google style break time 300 milliseconds. A numbers represent how strongly each feature is associated with the class label. After checking each feature's significance, I found features 0, 3, 5, 7, 8, and 9 to be statistically significant, meaning they can reliably differentiate between the classes. These are the p-values associated with the F statistics. A p-value tells us the probability of seeing these results by chance, assuming there is no actual relationship between the feature and the class. Break time 300 milliseconds. A low p-value less than our chosen alpha of 0.05 means the feature is likely important. Break time 200 milliseconds. A high p-value means it's probably just random chance. This is our threshold for deciding if a feature is significant. If a feature's p-value is below 0.05, I consider it statistically significant, and that means it's helpful for classifying our data. This is the function I am using to perform the feature selection. It's a statistical test analysis of variance, or ANOVA, F-test that helps me determine which features are most relevant to predicting the class labels. Break time 300 milliseconds. It calculates an F statistic and a p-value for each feature. The goal is to use fclassif to pick the most useful features from my data so that I can build a more accurate and efficient classification model. I'll be evaluating the truth of the statements provided based on the features selected after applying the fclassif function and considering a significance level. Let's see if this is true based on my analysis of the p-values. I'll check this statement too against the p-values. I need to count the number of selected features to check this claim. I need to compare the F statistic and the p-values to see if the feature with the highest F statistic is always the most important. We're working with a dataset that has 10 different features, and each data point belongs to one of two classes. Think of features like height, weight, age, etc. And the classes might be male and female. I am using the sayIsInterpret as characters fclassif sayIs function, which is a statistical test specifically, and ANOVA f-test to figure out which features are most helpful for distinguishing between the two classes in my dataset. I've set my significance level, or alpha, to 0.05. This means I am willing to accept a 5 chance of incorrectly concluding that a feature is important when it actually isn't. Based on the results of the sayIsInterpret as characters fclassif sayIs test, I need to decide which features are important enough to keep for further analysis. This shows the results of the sayIsInterpret as characters fclassif sayIs test for each of the 10 features. A higher F statistic suggests that a feature is better at separating the two classes. It's like a score indicating how effective each feature is at classification. These are the p-values associated with the F statistics. A smaller p-value means it's less likely that the observed differences between the classes for that feature are due to random chance. It's like the probability of seeing such results if the feature was actually irrelevant to classification. After comparing the p-values to my alpha 0.05, I've selected the features with p-values less than 0.05. These are the features I'll use moving forward because they show statistically significant relationships with the classes. Features 0, 3, 5, 7, 8, and 9 made the cut. Google style name excited awesome. Google style. I am working with a dataset that has 10 different characteristics or features, and each data point is labeled as belonging to one of two categories. This is a typical setup for a binary classification problem. Break time 300 milliseconds. These numbers represent the F statistic scores. Google style name lively. Each score measures how well each feature separates the two classes in my dataset. Google style break time 300 milliseconds. A higher F statistic generally means a better separation. These are the p-values, which tell me the probability of observing the obtained F statistic scores if there were actually no difference between the classes for each feature. A small p-value, typically less than 0.05, suggests that the observed differences are unlikely due to chance, and thus, we would conclude that there is a relationship between the feature and the class label. I've set my alpha level to 0.05. This is the threshold I will use to decide whether to include each feature. If a feature's p-value is below this threshold, I'll deem that feature statistically significant and keep it. Here, I will compare each feature's p-value against my alpha level 0.05. If the p-value is less than 0.05, I'll include the feature, otherwise, I'll reject it. After comparing the p-values to my alpha level, these are the features that are selected to include in the model. This is the question that asks to check our understanding of the feature selection process. This statement is true based on my feature selection process. This is also true based on my feature selection process. Correct. I've selected 6 features, so this statement holds true. This is a bit tricky. The feature with the highest F statistic might not always be the most important one. Google style name conversational. I care more about statistical significance p-value. Google style if a feature has a very high F statistic but a p-value above my alpha level, I still won't use it.